Well, hello. We're going to take a few minutes and talk about Lesson 33. This is Saxon, Course 2, Lesson 33. We're going to start out by talking about comparing decimals and rounding decimals. Now, it's really a pretty easy process, but I want to just take a few minutes and give you some steps that make it just a little bit easier. Okay? All right, when you are comparing decimals, the one thing that's really important with comparing decimals is that you have to write them in a way that makes them maybe just a little bit easier to compare. Now, to do that, you have to consider place value. Now, place value is determined by the integer's position in respect to where the decimal point is at in the number. You really can help yourself the most by aligning the numbers using that decimal point as kind of a point of reference, so to speak, so that they're all lined up by the decimal point. Now, to start, we're going to take a group of numbers and we're going to line them up according to their decimal places, and we're going to decide which one is the smallest and the largest, and we'll go that way and relist them, smallest to largest. Now, if you'll notice, I have these on graph paper. Graph paper is a really useful tool when you are aligning decimals because you have some guides. You have something that you can use to help you to line them up. The first thing you should do if you're trying to align decimals and trying to compare them is to write them one above the other, kind of stack. I call them stacking them, and you should line them up by the decimal. So this is what it's going to look like. Okay, you've got them all lined up. Notice that the decimal place is right here. 1.64, 1.612, 1.6, 1.593. Okay, now if you notice, there's a lot of extra zeros in here. Like here, there's 2 extra zeros, and there's an extra 0. The reason we put the extra zeros in is place value holders, because when you're comparing numbers, it's hard to compare nothing. So it's kind of nice to have the zeros in place. They don't change the value of the number at all. Okay, so when you're going to compare, you set them all up by the decimal, you add the zeros to make them all the same length, and then you begin to compare the numbers, starting with the integers first. And I've kind of drawn some arrows in here, so hopefully it isn't too confusing. Okay, look at the integers first, straight down. These are all ones, so can't tell anything by that. Then we go one place to the right of the decimal. We look at all of these numbers. Okay, oh, look at there. We have a 5. We have all these 6's, and we have a 5. So right away, we know that this number here is going to be the smallest. Okay, and so we can write that first in our list down here, 1.593. Okay, then when this number is eliminated, now all we have is 3 numbers to compare. We have all 6's here, so now we have to go to the hundredths place. We have a 4, a 1, and a 0. See, that's where one of those zeros is coming in really handy for us. So the 0 tells us that's the next smallest number. So we're going to get rid of that one. We won't be comparing that one anymore, and we're going to write it down here, 1.6. And we don't need the zeros once we've eliminated it from the list. So that's our second. We've got 2 left. Okay, we've compared the 1s, we've compared the 6's. Now we look at the 4 and the, whoops, that 1. So we know that it is smaller than this top one. So we could take it down here, 1.612. And all that's left is this lonely little guy right here, and he's 1.64. So we have them now smallest to largest. And there's your list. Really not too bad. It's not a bad process at all, and not all that difficult to do. Okay, and we're going to talk a little bit more about comparing. When you compare decimals, generally when you're talking about comparing, you're going to say that they're either less than, greater than, or equal to. So that's really the symbol that you're going to be putting in there. So it says right here, it says compare 7.1698 and 7.1689. Now, it's kind of hard to do that just looking at them sometimes because you might get confused. So, first thing you could probably do is just to rewrite them. Take out the and replace it with an open circle. So you remind yourself that you're going to put in less than, greater than, or equal to. Then, stack them. Now I'm going to go back. I'm going to cover this up and I'm just going to write them like this. 7.1698 and 7.1689. Now I'm going to compare them. And as I compare them, you think about what I've said about that before. We look at the 7s. They are the same. We look at the 1s. They are the same. We look at the 6s. They are the same. Now, we look at these two, and the 9 is larger than the 8. In this case, because 7.1698 was listed first, okay, and that 9 is larger than this 8, that is going to mean that this number is larger than this one. So, you can put it this way. So we know the 9 is larger than the 8, and the number is listed first. Therefore, 7.1698 is greater than 7.1689. Pretty simple process. Not all that hard to do. I really, really, really want this in your notes. Okay? It helps you to do things later on. Okay, we're going to talk just a little bit about rounding. That's an old topic. I know it is, but we're going to go over the rounding rules real quick to make sure that you remember them, because you never quit rounding things. When the digit to the right of the rounding place is 4 or less, leave the rounding place as is. Don't change it. So, 7.294, this is the rounding place right here. Okay? This is the number to the right. It's 4, which is, of course, less than 5. So, this is going to be left as is, only always remember that it's cut off right there. If it's rounded to this point, this number ends up going away, and you end up with 7.29. Okay? Secondly, when the number to the right of the rounding place is 5 or more, round up. Example, you got 7.198. 9 is the rounding place. 8 is the number that you're looking at. That 8 is 5 or more, so you're going to round up. But interesting, if this makes you round up, then this 9 becomes a 10. And when this becomes a 10, that means this becomes a 2. And that's one of those tricky things about rounding. So the real answer here is 7.20. One last thing I want to look at, and it's another little tricky thing about rounding, and I kind of like to talk about it. Some strange things happen sometimes when you're rounding. Okay, so what if you had 6.99 and you want to round it? No matter how you round this number, it's going to end up to be an integer, and I'll tell you why. Because let's say you're rounding to the tenths. You look to the right. That 9 is definitely 5 or more. So you go, okay, this has to round to 10. But it can't be 10 because the highest number you can have here is a 9. So then we have to carry that 1 over here. And then it becomes 7. That's going to happen anytime you have a list of numbers like 1.99 or 3.699. Look what happens here. This 9, if you're going to round to here, okay, automatically this 9 makes this go to 7. So that becomes a 3.7. This 9 goes to 10. So you end up with a 2. Kind of crazy stuff. Okay, if you have any questions, please feel free to ask me, and I will talk to you later.